I can clear it. Let's clear the results. Okay, so a couple of years ago, I saw Dana do this at one of the PERC meetings. It was really cool because how many people in here have not spoken at all or won't raise their hand? In the back row, raise your hand. None of you have spoken. So I'm giving you an opportunity that you don't have to speak, but you can anonymously write in questions or things that'll pop up on this poll right here. It's called Poll Everywhere. So I won't force you to try to be like Dirk or Henry or anyone else who's spoken, but you can still voice your opinion anonymously, because in the chat is type your name. Here it'll be anonymous. So on your computer, stop checking email, stop looking at your Slack channel, your news, and go to pollev.com/danv128. I'll put that in the Zoom thing. We have a limit of 40 responses per poll, which means you'll put it in Zoom. So after we hit 40, we'll have to start over. So if you're in Zoom land, go ahead. If you want to put it in the chat, have someone post it for you. I guess it'll be forced your job now.
When you say speaking, is speaking? I just did Zoom.
Okay. So our panel's name is Dana's Live Polling. That is not our panel name. Our panel name is how to help researchers identify the right resources for the research. I am the moderator. I'm Dan Voss again. We have Sid Burrows from the University of California, San Diego online. Sid, you want to wave? You are not Sid. Okay, we also have Pat Clemens, who was just on from University of Vermont. You are still not Pat. We're getting to Jim just came on. That is Jerry Perez from University of Texas at Dallas. Hi. Can you guys check to make sure when you speak, your faces pop up on the screen?
Yes.
Thank you, Jerry. Next, go Pat, Jim, and Sid.
Hello.
Okay, we got Jim.
Give it a shot. How's it?
There we go.
Can you? Okay.
Yeah.
There we go.
And then Pat, you're there somewhere.
Testing, 1, 2, testing.
You have a very clear video picture. Yours is very nice, all the way from Vermont. What a great internet! What a great internet tube backbone he has.
Yes, exactly.
Oklahoma. So, have you guys gone to Together added test 2? This test does great. So, remember we have 40 per poll because we have not bought Poll Everywhere yet. So, be gentle on how many responses you do. But we want to have this not a talk to you, but talk with you panel. No one has slides, which means we want to hear your stories too. We want to know how you help researchers find what they're doing. But first, we're going to have our panelists introduce themselves. You guys ready? Yes, all right. Go ahead. Tell us why you're on this panel and what you're going to hopefully contribute and get out of this hour. And Pat, you're the first screen, so let's go with you.
All right, sounds good. I'm Pat Clemens. I manage the cyber infrastructure and partnerships for Vermont EPSCoR, and also associate professor in computer science here. I am, like you said, part-time facilitator, part-time kind of strategy person for CI, and then part-time researcher. I also publish. So my perspective is kind of a little across the board. And what I hope to do on this panel, well, I just like participating in the community, and this is like my kind of way to give back. So I listen to you guys most of the time. I've learned a lot from everyone here, and hopefully now I can maybe have like 1 or 2 nuggets of knowledge that you can learn from me.
All right, Jerry, you want to go next?
Yes, I'm Jerry Perez, and I am a director for cyber infrastructure operations here at University of Texas at Dallas. Reason why I'm here today is because Henry told me I had to.
May you all keep that in mind.
And so that'll teach me to say anything. But yeah, so I've been involved in this field for some time, and I've got some information to share. But recently, I've had recent experience with Exceed and the Jetstream project, where we got some CPU time for my big data students. I teach at UTD's School of Business, and we have a very large audience, and so I had to get over 90 students access to the cloud so that we can run big data applications on the cloud. So it took a while to get it, but it helped solve some problems, and I'll talk about it.
All right, Sid, do you want to go next?
Sure. Thanks, Dan. I'm Sid Burrows. I'm from the University of California, San Diego. I'm a research facilitator there, and I am not in an HPC center, nor do I have an HPC background. So I have that perspective. My IT background is I was a IT manager for 13 years at another Southern California university where I worked with enterprise systems and made the change to research facilitation about 3 years ago. It's been quite a learning curve, and so hope I can share some of that with you.
And Jim.
Hi, my name is Jim Ferguson. I work at the University of Oklahoma. I've been here a little over 2 years, and I'm a full-time facilitator. My previous experience includes service at 2 of the national HPC centers, NCSA at Illinois, and NICS at Tennessee. Before that, a long time ago, I was a Fortran programmer all day, every day out in industry. So that's actually what got me my foot in the door and got my appetite whetted for high-performance computing, because we were definitely using that where I was. Hopefully, I can pass along a little information. Since I've changed jobs a couple of times, within the last decade, where I have to go out and find people and interact, maybe I can pass along some tips, at least that I found effective at my last 2 jobs.
All right, back row. What is the name of this panel? Anyone? One person. Yes. What? Oh, Jim. What is the name of this panel? What are we trying to accomplish with this panel? We're trying to accomplish Jim. I'm going to take Jim down.
I'll help researchers to identify the right resources.
Thank you for reading. Okay, so we have a couple, like Henry, read your screen. We have a couple questions that I asked the panelists to think about, and you. We're going to start with the first one. I'm going to put up the poll. Has everyone been to pollev.com/ what is it, DanB128? Okay, good. Back row, I want to see more than one hand. 3 hands, that's like 30%. Okay, that's good. We're getting somewhere. And remember, anonymous, say whatever you want. Please help, please say something, and let's break poll everywhere. So first question for the panelists, where do you start? Do you do the one-on-one versus group strategies, surveys, group meetings, benchmark? I know we talked a lot about this with intake interviews. Let's get some perspectives from the panel. Let's start at the top of my list. We'll keep the same order for now. So Sid will go first, Pat, Jim, and Jerry, and I'm going to put up the poll now. You ready, Sid?
Sure. So I think it depends on who's contacting us as to whether we start with a one-on-one consultation or whether we reach out to an entire lab. If the lab's involved, we certainly like to make an on-site visit and check out the situation, talk with all the individuals involved. Our main goal when we set out to consult with an individual or a group is to move that research forward. We are not a recharge unit on our campus, so there's no fees associated with consultations, and even with some of our work, our system integration engineers do. So we like to just be able to help these folks get their research moving forward so that they can get the obstacles out of their way. also to save them time. And so the more people, the more right people that we can get in the room at the same time, the better. And if that means we can identify some potential service providers prior to the consultation, we'll try to get everyone then around the table and have that talk, and then see what kind of things we can put in place to resolve issues and streamline workflows and difficulties that researchers have contacted us about.
Okay, Pat?
Yeah, so engagements start for me in a number of different ways. There's one-on-one, definitely, when a researcher sends me an email or comes up to me and says, hey, I have this problem I need to solve. I have one software developer that works closely with me, and him and I go to all of our group meetings. So we have a couple different teams that we work with, and we regularly go to the meetings to kind of sit in and listen as they discuss where cyber infrastructure might be important in their needs and desires, and try to kind of get ahead of the curve when we hear that something will be coming down the pike that they're doing, and we can provide some kind of service to help them out. We like to kind of be a little proactive that way. Sometimes I get it from faculty that are like, I need this student or GRA or postdoc to, do this kind of computational task, and so I'll seek out that student and work with them. So it always comes from a different place. And then as I move forward to think about the right technology, I wanted to stress that I think there's two main components to where to start. And one is figuring the right technical solution, but also is finding the right personal solution. We have researchers that run the gambit in computational expertise, from people that have never logged into Linux before to people that can code circles around me. So trying to find the right solution for that individual also factors into which technologies I have available to help them out, because I don't want the technology to be overbearing. I want them to be able to get their job done with the simplest piece of technology possible. And so there's always two things that go into all these decisions, and that is, what technology works best for that problem, but also what's not going to frustrate the user, and what are they going to be productive with.
And Jim?
Let me talk about something that sort of Henry did for Horst and I, the facilitators here at OU, back soon after I arrived. We went on a listening tour, as we called it, and Henry contacted a list of veteran and maybe not so veteran PIs that are already on the system to go around and meet their research groups, as much as they wanted to organize that and listen to see what they were up to. I'm pretty sure Henry hadn't talked directly to some of the PIs in a little while, and certainly I was meeting them all for the first time. Plus the students, some of the students I'd already interacted with one-on-one with email help. So that sort of group meeting is great if you have time for that, to especially to contact your sort of most your most important users, most important user groups. And sort of the other way to contact people is, I think we do some short, small introductory training sessions quite often. And it's not so much the training. The training is actually just about, it's like 2 45-minute sessions on basic Linux, and then how to use Slurm to put a job on the system. But the idea is to get people to go to the place in the library where Horst and I do consultation. We have regular consulting hours. And then some of the people, and many of them are new, will come back when they need help. They know where to go. They're not just sending email to the anonymous support email list. So that's that was another. I think that's been quite effective. And of course, sometimes you catch more people in the groups where people have one person has come down to take the early training or the mini workshop, and the next time they come, they bring a colleague along, or the next mini workshop we have the following week, because we do them sort of in clusters. There'll be another one or two people from that same group, usually new students, but sometimes students that have been trying to use the systems and have been unsuccessful. So those two things have been really effective for us.
How many people in this room do you guys go out and have classroom hours or hours in another place where you see, like in the library? Is that just, oh, what else do you guys do? You guys do that in Wyoming and Michigan State and USGS? You guys go out to have hours for your researchers? Wow. What else is up here? Someone said pi. I don't know what pi means. One-on-one faculty. Oh, capital P. I thought they'd have like a math data 3.14. Just pi. What else do you guys do? The entire number? Yes.
So usually from my group, when you create a new user, other colleagues, they'll send in the document, say, here's the document. But I found out 9 out of 10 times, you answer more questions by sending a document. So I always go one-to-one, and I tell them how to log into the system and help them with little Linux usage, and then submit a job for them. And this is talking with students. And so they learn how to do it. And usually there is another student who's shy who doesn't come, and they learn from them. So for me, that's more effective than sending documentation or sending an email. It's hands-on. So I go to their office, and I go to the student's desktop.
So one-on-one, hands-on introduction, make sure they know what they know.
Yeah.
Mohammed, what do you?
So what we usually do, like, first of all, like we have one-to-one meeting with the researcher, and sometimes that's required more people to be involved in the meeting, to give the best advice. So usually what we do, like if we have something that needs more than one advice, that we, in our meetings, we discuss this problem and we came up with a better solution.
How many people, even online or panelists, do you require your new users to go through the training before they have their account, or at least talk to you first, or is it just open?
We don't, but we're talking about it.
Usually training.
I know do you guys have to go through training, or you just have the trainings for people?
You don't have to. People just, we encourage people to do it.
I think so. Bob Freeman, who was on earlier for the carpentries, that he created a whole, I think it was a test and background questions to know to figure out what level you are at with comfort for the cluster. And then if you didn't know something, you'd go to one-on-one or have the training, but it was more of a, let's figure out what you do know, what you need to know, and what level you're at.
Our sysadmins are talking about making a quiz for the
Yeah.
policies, just the policies, not anything else, so that you don't just click the checkbox and go on without reading.
Just like everything you click online, yes, I agree to sell all my information to whoever.
Yeah.
So we require like training for either like one-to-one onboarding process, and we updated this process, and we're having the online course that included some quizzes, and you have to get like full grade to be able to succeed or to complete that course. Once you complete that course, or you complete a one-to-one onboarding process, so you will be able to get your password for the system.
Oh, that was even get your password to go on the system.
Yes, you can get your password unless, like, because people like then do it. We say like it's, not mandatory, but it's mandatory. People or users don't get their password until they get like the onboarding process or they completed the course.
Okay.
So does it scare your users? So
No, actually, it's very helpful.
that's all I don't want to.
Because we are scared about our system.
Oh, do we?
We haven't heard from Jerry yet.
I know. I was trying to break it out with all the poll going on. Jerry, you ready?
Yes, I am. So we ask our users a list of questions, especially if if they haven't worked with us directly immediately. So as you all may know, all of your campuses still have users waiting to be approached by you. They don't even know they're your users yet. And so that's part of our task, is to get them acclimated and aware of the infrastructure and how it operates. And so even though we may have our regular everyday users, there are still people out there who do need our services. And once they discover that there's a cluster on campus or a service on campus, we should have a set of boilerplate questions already ready for them, such as what is the nature of your application? What are you trying to do? Is there a particular application that you want to use? So each science has its own pet application suites. So if you've been in high performance computing long enough, you get to know which applications that usually come out of the box that are popular for each field. You know, whether it's electrodynamic simulation, or if it's a biological database search system, or big data for that matter. There's a whole suite of applications that go with the field. And so so when we figure out what the needs of the customers are, we then can facilitate running those applications on the system. But of course, we have to ask some other big questions that we sometimes forget, such as how much data are you going to produce? How much memory storage do you need? So there's a couple of things that may actually run into the user having to invest into the cluster. So here we have a model where if we don't have the resource available, that the user can buy into the cluster through a condo model. And if there's a particular type of architecture that they need, then we can help spec that out for them. We have a very good relationship with the vendors here, and I don't need to list them here, but we have a good relationship, and so we get timely turnaround times for quotes. Also, we get some help with engineering, so they have a good engineering team that helps point us in the right direction to select the best cyber infrastructure for the users. And so we've done that a couple of times since I've been here for about a year at UTD. And but this is something that we have to keep in mind when we associate with the users, and that is sometimes they don't know exactly what they need. I've heard that before spoken about today, that sometimes the users don't know what they really need. And so we, being the experts, need to help them understand that need and try to get it to them in a way that hopefully won't break the bank. So we're trying to facilitate with what we already have, but if we don't have it, then find a solution that everyone can be happy with. And then, of course, tailor the documentation that goes with the solution. And so that's been my mantra ever since I got here, is document, document, document. You cannot go wrong without documentation. I know some folks say that they don't have time to document, but really we need to document. And so what that does is it makes not only our own jobs easier when we onboard new employees, but it also helps the users do their jobs better because there's something written down to help them do their work. And so we have a very basic document that we send our new users to where they can begin learning how to submit jobs to the cluster, how to create submission scripts, how to manage their data locally. So we point that through an internal website here at UTD.
Thank you, Jerry. Okay, so we're going to go on to our second question, which you guys have already started answering on the poll. Strategies for research not in a field you or your team understand. So this entire week, there's so much overlap in what we talk about in the different panels and the talks, and we've had that, and I guess Google is a big one. So Sid, that you're even new to this area from IT, let's hear your drinking out of the fire hose into helping researchers from the facilitation standpoint.
I'd say probably 95% of the researchers we work with are not working in fields that I understand. My background is in spatial science and GIS and archaeology, and that's also where I did my research. And I work with folks in health and the humanities and engineering all over the place. To sort of echo what I've heard in previous panels today, Kyle talked about the warm handoff, and we talked about developing relationships. Listening to what the researchers are saying during that intake interview, developing relationships with them, and basically understanding their workflow, where their pain points are, and what they're trying to accomplish. They all have goals, and if we can pull apart those goals and identify the proper services or service providers who can help them, then we are the conduit to connect them to those services, and don't necessarily have to have that specific expertise in their field. I think, again, I've heard earlier, they're the subject matter experts in their field, and they're coming us to tap into our expertise about things that they don't know, and to obtain resources that they're unfamiliar with. So together, that relationship is what is so powerful to get them moving forward. I think oftentimes too, during that intake interview, when we're just listening to them and we're talking about their research, they get really excited. And that was something that came up earlier. Folks were saying, yeah, you can tell when someone's excited about their research and they want to talk about it. And you learn a lot at that point. And oftentimes we're able to find little pain points, not what they came to us with, but we can identify other ways that we can streamline their workflow, and that sometimes makes them really happy.
All right, Pat?
Yeah, I think it's a skill that you tend to pick up after you do this for a while, on how to keep the conversation focused on the technology and not the nuts and bolts of the model or software that they're running. Researchers, like Sid said, researchers love to talk about their work, and often I find the conversations lead to, the intricacies of the hydrology model and how water seeps into the soil, and, on and on. And it's always a skill to kind of try to redirect that conversation back to how they do the work, the computational aspect, and keep them out of the weeds. And I think it's just practice, trying to the redirection. But I think there's an interesting corollary to this. That's and that is, when you have turnover in researchers and someone comes in, sometimes I get people come up to me like, hey, do you know how this hydrology model works? And I'm like, well, I can run it, but I don't really know what's happening on the inside. Or, do you know how this model works? And because I know how to make it work and produce output, all of a sudden I become the expert. And so there's another kind of redirection there where you need to direct them to, like, either their predecessor or someone else in the university that knows what they're talking about, and make sure that you know your stuff really well, the technology really well, and then have them refer to other folks for the modeling aspect of things. One thing I also do, now I think about it, when I sit down with somebody, is I almost always make them do their workflow in front of me, and log into the server, or whatever tool they're using, the virtual machine, and I watch them do their workflow. And that really helps me understand, extra keystrokes they're doing, or extra, data manipulation they may not need to do that we can help automate. And that really helps me see pain points they might not know that they can get rid of. And that happens a lot, actually, where, I'm like, well, I could automate that part for you. And the eyes light up, and I didn't know I could, you could do that. So I think it's important to kind of spend some time with them and watch them do their work, and watch them, go through their workflow, because a lot of times they don't know what to ask for. They don't know what technology can do for them. So again, it's you being good at your job and helping them do theirs, and letting them do their job well.
I like that. They don't know what technology can do for them. That's why we do this. All right, Jim, what do you got?
Well, I certainly agree with all that. I'm going to jump on sort of a normal case. It looks like, in my observation from a couple of years here, where we have new people arriving, and you know, and they could be from OU, they could be from the Health Sciences Center, meaning they're arriving and they're used to using a certain package or number of packages. And in that case, you know, sort of we build and load software for everybody who needs it now. You know, the free stuff, right? You got to pay for it, then the research group has to pay for it, and we build and put it in the module system. But when someone comes in with you know, with a list of 7 or 8 packages that they need, then the questions are a little bit different. You know, what do you expect to get out of the Schooner cluster that you're not getting where you are? Sometimes they have some very good answers for that. Sometimes they're not looking for so much more capability that Schooner might have. They're just looking for more capacity somewhere away from the current departmental server that they're struggling to get some time. And that's fine. But oftentimes I find these groups surprised, say I need these half a dozen packages built into the module system. And you know, we'll go check, and maybe we've already got 3 or 4 of them in there. Sometimes those users are surprised, like they didn't know anybody else was doing that sort of thing here. I don't really follow up on that, but I wonder sometimes if they're wondering who else is doing similar type work, maybe in the office upstairs from them. But I don't really have a particular point here. It's just sometimes when users come in, even you know, outside of our area of expertise, sometimes they have a good handle on what it is they want to do. Sometimes not so much. Sometimes they're just well, they're looking for more capacity. It's not so much that they're looking for extra capability that our larger cluster might have over their resources. So sometimes it's simpler.
Okay, thank you, Jim. Jerry?
Yeah, so sometimes we get some users that we assume are just fine, especially the ones that have been doing their computation for years. But then something happens, and for example, and it doesn't happen on the main cluster, but they may be running their own smaller clusters, and they're just assuming that everything's going to, you know, operate the way it should forever. But some of these experiments, some of these projects that they work on have technical drift. And so what does that mean? It means that things change, and technology changes, and methods change, but the user isn't aware of it. And so we sometimes have to step forward and actually learn the nuts and bolts. I've heard someone just mention that. The nuts and bolts of how their operation works. And so we have to step out of our comfort zone, because we're used to loading applications onto a cluster and creating user accounts and maintaining hardware and software. That's pretty much our domain. But then we start having to learn other things outside of HPC to help the user do their work. And so that's one of our challenges, especially if they've been working on a project that's been going on for years and years and years, and the project itself is long in the tooth. A good example of that would be Open Science Grid. You have to stay pretty much in the know as to what's changed in the last couple of years to stay current in it. And fortunately, we have some pretty sharp people here, and we've been able to help rescue one of these projects. But that's just an example. There are others out there that require our learning how the software works, how the cyber infrastructure works with respect to the project. And again, that goes outside of the normal daily operations of research computing, other than we're going to have to learn another suite, another set of research tools that aren't used by everybody every day. But I think that comes with the territory, especially when you get used to working with, folks in particle physics, people doing the Higgs processing, the CMS, the gravity waves, and then getting used to the chemical electro simulation people in chemistry. You have to learn their suites. You have to learn how it operates, and then help the users understand any changes that may have taken place with or without their knowledge. So just to make sure everybody's on the same page so that there's no disconnect when we're communicating with the users. So that's something that we have to keep in mind and help them, because sometimes the users don't read the documents. Sometimes the users don't stay abreast of the changes that have taken place, whether it be the application itself or authorization, authentication mechanisms in the system itself might have changed. So we, being the facilitators of technology, have to go and do that extra effort and help the users stay in business, so to speak, by taking the extra effort of learning how their operations work and keeping those operations functional.
Thank you, Jerry. I haven't been reading. What does our poll say? I like that Google pops up almost in every poll. That's great. That's how you fix all the problems. YouTube and Google, which is owned by Google. So, or sorry, Alphabet Soup, ABC, whatever. So, ask researchers to explain it to you like your 12-year-old. But remember, explain it to you like your 12-year-old, but assume they're a what? A 5-year-old. Who said genius? No, 5-year-old. So, I mean, if they're in their field doing the research, you just have to help them get where they need to go. And I love that people talk about the hierarchy of physics and computational chemists, but we're in the world of long-tail science where you have anthropologists and English majors and like doctors. I have doctors now, which they're like, help! We don't know what to do with this thing. Needles and stuff. And that's a great place to be, because you are their bridge to helping them understand technology they understand. What's weird is we haven't even talked about technology, right? We're just talking about how to talk to people, which has been a lot of stuff this week. A lot of Dirk's background too, how to use your communication to understand what they need and what they could use. How many people, so when you talk to researchers or have it, do you think they know what they need computational-wise, data-wise, how their stuff works? No. Unless they really build their own clusters, which a lot do. And even if they do, they don't know. I asked just a couple weeks ago, Henry.
So I would say the answer to that question, do they know what they need, is essentially the inverse of the long tail. How involved is their discipline with research computing?
Yeah. Because high-end physicists, they know they need more than they have. They split out the entire world. The rest, of course, right? So, but you've been doing it for how many years now? How long have you been doing the experiments?
Well, I've been doing it for 29. I'm sure other people have been doing it for much longer.
What,
They're a totally different case.
Yes.
Hierarchy physics, they create cyber infrastructure to get what they want done, whereas most other researchers, they see everything as like, well, these are the tools I have, so this is what I'm limited to doing. Whereas, it's kind of the opposite side of things. And I think the vast majority of researchers have no idea what's possible.
Yes, they don't know what's even possible to do, or they don't know what it means. I'm coming down to my next question, which is, I think, the next one. First, let's finish reading. So we got brainstorming, which we talked about today, 12-year-old research groups. Exceed, I'll plug Exceed again. They have domain champions that are specific to certain domains. And then Carrie, who was here 3 years ago, what is Carrie's last name? She is part of NSF. NC Gas. They will come out and give biology workshops to you and teach you how to run bio workflows and how to do things. And I think Attack to Tech puts all of their bio packages in some Docker repo somewhere. So there are people who can help you do things that aren't in your area of expertise. Comments, questions? What do you got?
I got a question. So, kind of spinning off of your question and going back to that, like last time, the dumbest question I could possibly imagine to ask.
There are no dumb questions.
If the researcher doesn't know what they need, how am I as a facilitator?
Well, that's our questions 4 and 5. We're going to figure that out. That's your job, to figure out how to help them get
So I have to be familiar with every tool possible out there, so and know what its practical application is.
No. So when you say tool, what are we here for? So we have a
I'm
basic.
not writing the code. I'm
Yeah.
talking about just, facilitate.
So I mean, we can have the panel answer that too. But who in this back row of our room has any answers?
I was going to say one of the advantages in doing this sort of facilitation is you get to talk with many people doing different things, sometimes the same thing. And then you can say, so and so is interested in doing this. Is this something you've done before? You can connect those people together.
There's a paper, 1980 something, that had there's 7 basic computational algorithms and how they do. So most things break down to, if you understand what they're trying to do, which is talking, communication, reading, checking, Googling, looking at Wikipedia, you figure out what problem they're trying to solve. This is back to communication, what they're trying to solve, talk to them, see what they do now. If they're starting from scratch, that's a whole different world. You're not going to write more software for them. They have, which is our, man, you're jumping ahead of my questions. Homegrown code versus community code. So let's go there next. Yeah, Mohammed.
So the thing is, I think the researchers, they at least know the goal, though. Like, what's the result, what they want to do, but they don't know how to do it.
Or what is their limiting factor now? I'm running on my laptop, and I can't check my email because this thing just doesn't finish and doesn't my hard drive.
So usually, yeah, they know what's the goal of their work, but they don't know how to do it, or what's the best way to do it. So it's like, it's our job.
I'm going to put a shameless plug-in for my talk tomorrow morning at 10:45 a.m., which I feel like a lot of the questions and comments here are presaging what I'm going to talk about. Mine's going to focus on non-STEM disciplines, but a lot of these questions still are prevalent. You know, how do we know what the researcher wants? How do we make the researcher understand what's possible? How do we guide them to the right tools? These are all going to be things that I hope we can have discussions around tomorrow. So, you know, I hope we don't take too much wind out of my sails right now, but, you know, clearly these are important questions that a lot of people have.
And I think your talk is actually the one that my question was truly geared toward, is because like when he was talking about responding to problems they're currently having. I spent the better part of my career responding to issues. I want to be able to transition over to forward thinking and proactively eliminating these issues before they arise. So if I can get engaged earlier in the process and say, you don't necessarily want to be looking at this tool, you want to look at this one over here, because I know it's going to avoid a potential issue down the road. That's where I was kind of, you know, that's why I took it all the way back to a 5-year-old. How do you know when they don't? So that, and it kind of does breed. I have to be very familiar with what tool sets are out there and what some of the common issues are with those tool sets in relation.
So, Richard, let me respond to that a little bit. So, you're setting yourself an impossible task. Remember, there are thousands of those codes out there. You cannot become even passingly familiar with even a corner of them. So, if you start from the premise of, I need to understand all the tools that might be relevant to my users, you've already lost. What you need to be able to do is help them find the answers to those questions, not to know what those answers are. Knowing what the answers are is an impossible task.
And plus, once you know them, they'll change tomorrow.
Yeah, absolutely.
So we will always be on the chasing the 8-ball side of things.
So this is the nature of research, and therefore it's the nature of research computing.
You can at least eliminate the most
And you're not chasing, you're leading.
Right.
You are with them leading to the next thing.
It's always
You are
the
helping them. They're like, oh my God, I didn't know I could do that. That's great. How do I do this? It can be as simple as I help them put their grad students into a Git repo so they had code revisions for the next grad students and postdocs that came along. Simple stuff like that.
Yeah, not everything changes.
Yeah.
So let me tell a story just from maybe a month ago that I think captures this pretty well. So a researcher sent us a note and said, I need such and such code deployed, ortho, whatever it was, ortho MCL. And we looked up what it would take, and it was designed essentially to not be able to run on machines like ours. So then we started Googling, and we found P ortho MCL written by somebody else that did the same thing in a way that aligned beautifully with our machine. And so we wrote back to the user and said, would you be willing to try this other thing that their web page says it does the same stuff in a different way and runs faster? And the researcher said, sure, let's give that a try. Now, it might have been a big failure, and that would have been okay. We were prepared for the possibility that it was a failure. We couched the question to the researcher in terms that admitted in the question that it could be a big failure. But it worked out to be a success, and the researcher's very happy, and we're very happy. If that had been a failure, we'd have had to try something much less palatable to one side or the other. But by being willing to experiment on both sides, we were able to come up with a good solution. We got lucky, but you won't get lucky if you assume there's a right answer. There's no right answer. There's a bunch of names.
And then also know that they knew that code will work on their system. The researcher doesn't know that.
Right.
You should know that. You should understand that. You Google it. Stand up for the Google share. Google, stand up. Everyone sees the Google. There you go. When you Google, you can filter better than they can sometimes to understand the underlying architectures, what you can do in the system, what you have. So just understanding that part. You don't have to understand all the research, but knowing how it fits into your infrastructure. That's a big deal. They have no idea.
They have no idea what your university or your institution has to offer or can offer, what you can offer. You know that, and you have ideas around that.
Meaning is basically know what worked in a previous problem, and that's what they're going to tell you to do. Best case, they can give you several options. Worst case, they're going to pick something that is wholly unsuitable.
Yeah, I think that's an excellent point. And they may think that's the solution because their colleague told them that's the solution. They may think that's the solution because they read about it in a paper that discussed the same problem. Neither of those means that's the solution, and neither of them means it's not the solution. What you have to let go of is the notion that A, there's a right answer, and B, you need to know what it is. Both of those are going to set you up for failure. We're going to work together to find the best of a bad bunch of options, is what the actual response is.
Now I know where maybe it's the art of the possible.
Yeah.
This is fun. So the panelists asked for this. They said, we don't want slides, we want interactive. Are you guys enjoying this? Is this what you expected? Okay, good. So we won't get to our questions, but you're touching on a lot of them already. So my next one was,
Hey, Dan?
yes.
Just quickly, before you move on, you were talking about like third-party, like outside resources. And I just found out this week about an NSF-sponsored project up here in the Northeast called Northeast Cyber Team. And it's kind of like the Exceed domain helpers, or I forget what they're called, domain experts. But it's a more general purpose. And so it's like it's a website where you can go and post your kind of like programming CI kind of issues, like around a research question that you have. And then there's some funding available for students and grad students that are funded, undergrads, to participate in those projects. And they receive a small stipend for participating in these projects and moving them forward computationally. And so it's kind of like a pilot project, up here in the Northeast. And if it works well, I would imagine that NSF would look at moving something like it forward. But it was kind of a neat idea, and I thought it was kind of a more generalized version of exceed model.
Is it only for Northeast universities?
Are you talking about ask.ci?
Yeah, well, ours is called Any Cyber Team. There might be it might be a regional thing. I don't know if other regions have a similar thing, but ours is, if you go to Any Cyber Team and search for that, it's like the first hit on Google. And you can see that there's some projects registered there, and then there's a list of people and. NE as in Northeast Cyber Team.
Yeah, so that's a cool group. So Julie Bond, that group is leading the ask.ci or ask.cyberinfrastructure.org, which is a discourse site for this community, kind of like Stack Overflow, but for research computing.
Cool.
Yeah.
Okay, that's awesome. Thank you. Our next question out of our 6, so we won't get to all of them because we have 5 minutes left, I think. Unless Henry gives away some of his end of day time.
I think you can go till
quarter till if you want. If you don't, we can stop earlier. But these are just, these are just trying to see the ground of what you guys want to think about. So for the panel, like technical limiting areas, homegrown codes versus community codes, and how do you explain to or understand if the codes are CPU bound, memory bound, accelerator, storage, network? Sid, take it away.
Well, this is a really great question for me because I don't know anything about the codes. And I'm not in an area of HPC, as I mentioned initially. So the way we handle it as facilitators on our campus is we reach out to the developer community and find out if there's someone with a specific area of expertise that might be able to help a researcher. Also work closely with the help folks at, obviously, OSG and Exceed and that kind of thing. But this is something I'd like to know how other facilitators that are more generalists like myself handle this on their campuses. Anybody in the room in this uses me?
How do you guys handle knowing how codes are CPU, memory bound? Google. Google.
I can say something a little bit.
Finding things, that means like it's usually memory bound versus like.
But how do you know?
You should look at the code benchmark.
Or maybe you can't look at the code.
Even though
it's not going to look at the code.
Okay, so you can sometimes ask the person or like.
So
what's the
assume
program
the
doing?
researchers have no idea. They don't know if it's storage, memory, CPU. They don't know. The grad students don't know came in from whatever.
You can't give me like a code to like a file and tell me this is.
You run it and run top.
Yeah, that's true. That's true. This is the way you run it and run top and just.
Okay. Who is? Hello. You have a comment? This is.
Yeah, just repeating what Dana said. Usually, if it's someone new and it's code I'm not familiar with, I benchmark. If they know how to benchmark, awesome. Otherwise, I do it for them. I compile, run, look at job stats after jobs are done. Yeah.
So, has anyone here used a profiler before? QProf? Quite a few. Intel VTune? That's a few. That's not bad. Valgrind. Yeah. Vampire. There's a great talk at Supercomputing for Vampire and that's that.
There's another one called LoopProf.
Yeah. There's many. They're hard to use and they're weird, and you have to run the code first to make it work. Who's next? Pat, what do you got?
Yeah, the benchmarks are like the right way to do it, especially spoken as a computer scientist, background. But it's really long. It's laborious. You have to have the dip. You usually need the debug symbols, and I find that I personally, don't have the time to do that for every question that comes up. So like htop, top. Are my go-tos. I have them run the code and I watch it work on the machine. And
can you explain htop versus top?
Oh, HTOP is just a fancier version. It's like it's a couple more options, but there's many of these. There's a Python one that I came across recently that I really like. That escapes me too. But they're just machine monitoring tools, right? And so you can watch the memory usage and the CPU usage across the machine by user and by process. And this gives you a really quick idea of what's going on. And usually the only reason I'm aware of it is a user comes to me and is like, this code's running really slow, or this code keeps crashing. I keep getting, page frame errors. And then I, work with them to figure it out. The most common problems I see are my code's running slow, and then I help work with them to, if they're, it's usually homegrown code, and they'll, I'll help them parallelize it in R or Python. That's the two or more common ones that are used with our research group, and help them parallelize it. I often get memory bound issues where they try to load huge data sets into memory, and even with our beefy servers, it fills up their memory and crashes. And so I help them think about ways to kind of take intermediate steps and break the problem down. A lot of times they'll like load the same data in 15 different times with slightly differently named matrices as they move along their workflow. And so it's teaching them how to like store it off to a file if they don't need it anymore, to read it back in at a later date when it's when it's needed. So it's a really hands-on process, but again, just those quick little tools to kind of get a sense of what's going on, and then working with the user one by one to give them some skills on how to kind of get around these problems with code.
Dana had a hand.
I wanted to kind of touch on the idea of how much time should you spend, like, sucking every ounce of juice out of the CPU or this or that, or when do you go into the code and spend a lot of time manipulating the code versus just throwing more hardware at it?
So what was Henry's, you have a response to that. What do people complain about with time on their jobs running on Oscar?
How long they wait in the queue before the job starts running and nothing else.
Right. Well, and so, but I see people, well, like with memory bound, right? So if you're at your limit on your standard nodes, let's say, do you try to figure out what they're doing that's taking up so much RAM, or do you just go ahead and throw them on a large memory node?
So what is your, so the question is back to first, what is your job? Are you part of the infrastructure team, or are you a software engineer for that code, and you want to have code changed? How much effort do you want to put into it?
I mean, as like a facilitator.
As a facilitator. So how big is your group? How much do you put on your plate? If you can dive into code, you might be a domain specialist in your group. And of course, I would say yes.
Yeah.
If you are the person that does the debug, the machines, the network, the storage, and
Well, and it also matters how often that code is run, right? Like if it's higher physics that they're going to run times, then you want to optimize that completely. But if it's like a bioinformatics code, that's pretty much hopeless no matter what you do. And they only run it for 20 minutes a month, then who cares, right?
Most of the time what I do is like, I look at what program options there are for the software. If you can run on a GPU, I want to make sure that it's actually using it. And whatever, kind of look at, see what things I can do to help speed it up that way. Not so much of splitting it on nodes, because more than likely it's just that it's not enough memory to blow up anyway. But that's the part, is trying to get it to work the way it's supposed to.
how many people here are familiar with XDMod, OpenXDMod? So OpenXDMod and XDMod, they're used on the Exceed machines. They were developed under an NSF grant out of Buffalo by, we'll give him credit, the guy running Perk this year. Yeah, so his group wrote this code, and it can also, if you were on a cluster, track job usage stats. What you got? There's a plugin that can do networking, memory, CPU, and monitor things for you, which is also a tool you can use for people's codes. So you know, hey, these are the jobs you ran. Here's what resources you can use, how much network, how much it does, how much it does, and network ID, storage, a lot of that. I don't remember the name of the plugin, but they do a session at Perk, which they did last year, that will teach you some of these things to help you understand people's codes. without digging into the code, just
So is it
understanding
more
what
of
it
a
does.
monitoring? Is it more of a monitoring?
Yeah,
tool?
it's totally monitoring, but it will give you per code monitoring numbers.
Okay.
And is that a deal for the entire job, or is it breaking it down on the lifetime of the job, minute by minute?
XDMod does a historical. You can save every job, everything. So
Right, but, so, whatever the scheduler, like S account, is a snapshot of that. Right. Even with these plugins. So it's a per job metric.
per job, per user, per
They,
you do
they
a whole bunch of
reserve,
things.
they reserve so many CPU hours, they ended up using so many because their code was only running 50% of it.
Right, the granularity is the
It's
job,
per job.
not, the minute of the runtime.
Right.
There's a lot of options if you want to learn, if you want to know more. There's, like I said, probably another topic perk I didn't look this year, but they have a lot of information you can do with XDMod to help you figure out what jobs you're doing without having to dig into the code or use a debugger or use a profiler. It's a higher level to understand what happens.
So you have to have the job accounting set up, right?
Yeah, as long as
Yeah.
this account works and it pulls that information and sticks it into a database of its own, and it gives you a web interface to it.
And I think it works with other schedulers as well,
Yes.
right? It's not just.
No,
sure it
it's been around for, yeah, it works like all the schedulers, all the things. It's very good, very detailed, and great graphics for anything. If you want to know group usage, job usage, person per CPU, per node, everything, it does great things. But it does dig into, with this plugin, can't remember the name, I was like, that doesn't match. It's one of those, what is our group specific name that shouldn't match something else. So.
I heard that the new versions.
I have not tested it.
There's a bridges, PSC bridges on them.
Find out.
I'm pretty sure it'll show you stuff like CPU utilization, like the average CPU utilization, average memory utilization, stuff like that over the time frame of the job. It won't show you minute by
You
minute.
have to have like tax stats or something.
Yeah, so there's a plugin for it that does that. Without, so there's a tax stats, another one called someone who's Google shirt. Can you Google that for me? Google XDMod plugins. And what's your name? Andrew.
Did you just ask Google his name?
It's like Google Assistant. The perfect data. Everyone's saying Google is your friend. All right. So Jim, do you have any comments, remarks for?
No, hardly anything to add. I mean, I agree with Patrick on his approach. I'm not as knowledgeable at Python as he is. Likely, I'll maybe have people, if they have their own homegrown code, show me their par4 statements, and I'll inform them later that yeah, you're only running 8 threads there. You don't need to ask for all 20.
All the
cores on the node, and in Fortran and C, I haven't dug into codes here like I have at some other jobs, but I'll look at simple things like I'll ask the question, are you doing any mathematical operations in your homegrown code? Are you doing any matrix multiplies? And if they are, I say, are you using a library or did you write it yourself? And so, I'll point them at numerical libraries if they didn't know what those were, because they're going to be faster than anything that they've written in C or Fortran generally. They're just going to be more highly tuned. And I guess that's about it. I might look at their compile line to see if they're actually turning optimization on, see if that helps or not, see if they're, what big O optimization level they're at.
Can you explain
that they're having problems too, right? So,
Jim, can you explain the big O?
And they do a minus capital O3, and for some reason their code's not running well. Well,
can you explain what big O means for a compiler line?
Generally, in C and Fortran compilers, that's just an optimization level. Generally, it runs from 0 to 3 on compilers. Some places it goes to 4, I think. And the higher the number gets, the more unsafe the optimizations get. The more assumptions that the compiler makes about your code, that your code is nice and well behaved. So you can start at 0 and crank it up until your code doesn't run faster anymore or doesn't work. So that's that's another thing you can do that's simple to suggest to the user. They could take it back with them, and but the first thing I ask is about the numerical libraries, to make sure they're not trying to write things that have already been solved and solved very fast for them by other people.
Thank you.
Yeah, Jim, just on that, you're right. The numerical libraries are really helpful, and I've come to love a couple R ones that I recommend. Around like dplayer is great for reducing the memory usage, and there's a couple Python ones that that move data use or that move data processing to the GPUs. And so, just looking to see if we're able to take advantage of those. That's a really good point.
Jerry, what do you have?
Yeah, so basically what everybody's been saying in different words is the application of the software development lifecycle. This is one thing that I think we need to make as a habit, and that is when we come in front, when we get offered software we've never seen before, we have to assume that it's running in the worst state possible. And so we put that onto the software development lifecycle, where we first identify the, what are the requirements of the application? What is it trying to do? And so I've heard people talk about memory constraints. I've heard people talk about GPUs. I've heard people talk about optimization. All these things play into the software development lifecycle, and then it then plays into the proper way of putting it together. This is where David Chen came in. This is where Patrick and Jim were talking about compiling it and having it operate in a particular way that it should be operating at its optimal level. So that's something that we have to incorporate as facilitators of cyber infrastructure, and that is we have to help the users understand the requirements of their own code, because in my experience, a lot of the homegrown code wasn't even homegrown by the person who wants to run it. It was homegrown by an associate, a peer, a colleague, their PI, who's no longer there, by the way, and didn't leave any documentation either. But somehow it's still in use in a research group, and we're trying to help them understand how it works and how to get it working better. So again, it's the systems development lifecycle. You can Google it. It's a very sound way the folks in computer science go through and care and feed for code in its lifetime. But that's basically what everybody's talking about right now, is the application of that method, that system.
Thank you, Jerry. So we don't say Google it anymore, we say Andrew it. Andrew is now Google. What'd you come up with plugins for XDMod? Nothing? Okay. I'll search for it and I'll post it on the slides. We have like 5 minutes left. Let's get to the crux of how to identify what resources. So we've learned a lot this week about how many different resources are out there in the national, public, private, cloud, local, desktop, whatever. So my question is, where do you point them, and how do you know where to point them, which is what we've been covering the last few questions. So when you decide to go to exceed public, private, IT, your own, Sid, take it away.
Thanks, Dan. Well, we spend a lot of time understanding and getting to know the resources that are out there. We have built matrices in a shared collaborative environment that our team has, so that we can easily filter through features and eligibilities and size limits and all the kind of things that a researcher is going to want to know when we're pointing them to Exceed or OSG or other clusters on our campus.
Is that public or private matrix?
It's private. It may be able to be shared, but a lot of the resources in the matrix are campus services. So we have a few clusters on our campus that are managed by the departments, and they have specific criteria for who their users can be, how long they can be on there, what kind of things they can run. So we've filtered all that down, so we've got a lot of detail. We try to really stay on top of services and service providers, what they have to offer, especially things through SDSC, where we're located, because it's just a really complex environment to navigate. And when we're sitting with a researcher in a consultation, we want to be able to speak intelligently about what their best options are. You know, what type of programs they're going to be running, how long they're going to need those resources, you know, what type of speed they're looking for, how long it takes them to run a job currently on whatever they're using, make those comparisons, and then, you know, point them in the right direction. But some of the other things that we also like to take away from some of those consultations, we learn a lot about what's missing on our campus or in general. Licensing, for one thing, we learn a lot about. Recently, we were able to leverage a lot of researcher requests for Globus, for instance, and we were able to put together a standard licensing subscription so that it's a campus-wide resource now, which we didn't have before. So a lot of our conversations allow us to leverage that information at a higher level and get new resources supported for those researchers on campus. We point them to things like software carpentry, which I've heard mentioned 1,000 times already in the last few days, and we have a silver membership through them. We offer workshops, and as someone said earlier, the workshop itself and getting them trained isn't necessarily the objective of getting them in the room, but it allows us to make those contacts and develop those relationships, and those relationships often allow us to, you know, leverage those kind of things. So a little off topic there, but down a rabbit hole.
Oh, that was good. That was very nice. Pat?
I'm going to list like 3 principles on kind of how I decide this, and it's probably more than I'm missing, but 3 are coming to mind. One is, don't give them anything bigger than what they need. It's a waste to send them to, you know, a huge resource when they only need like 1 processor or, you know, a little bit of memory. The second principle is, don't make it any more complicated than it has to be. And then I think kind of the third principle that kind of is best, you know, borrows from the first 2 or is related to the 2 is, I try to keep it as local as possible. That's not to say that like there aren't great resources outside of the university or outside of the region, but it always tends to add to the complexity, and it always tends to make it bigger than what they need if you're the further you move away, and also more expensive. So those are kind of the 3 principles that come to mind right away when I think about this. And then related to that, as you move up and as they need more resources, always test it at the lower level, because the bigger it gets and the more complicated it gets, the more expensive it gets. And you don't want to waste your money without testing it on the smaller data sets first. So I always have my users, you know, reduce the data set to a small test set, make sure it runs on a comparable local machine before they try to take the big step and waste all the allocation hours or, you know, the cycle hours on Amazon Cloud.
That's good. Jim?
Well, real quick, let me talk about, you know, the resources here at OU. We try to point people at our own resources mostly, and we have a small private cloud, and of course we got a cluster that is about 300 nodes public, 300 nodes condo, and so, you know, the needs of our researchers as far as those computational resources, most all of them can be fit in there. You know, we have some users who use outside resources, mostly atmospheric scientists, and you know, they'll use something larger and up at NCAR or maybe one of the Exceed centers, and a few others as well. But as far as you know, I guess I wanted to take a spot here. Let me just do 30 seconds to admonish folks that are new to research computing facilitation. Whether you've gone to a new university or you've been switched to that role at your current university is to go out and find those human resources that are available and already doing things to help users around your campus. It's surprising how many folks I dug up at Tennessee, and not so surprising here at Oklahoma. It's much more tight as far as the computational crowd. But I was discovering people who wanted to help, and had a certain percentage of their time assigned to that. After years, a few years, the last place I was at Tennessee, and it's I thought I'd gone and looked behind the bushes and dug everything up, but that wasn't the case. You got to keep looking. So there are people out there who are already doing this, maybe in their particular research group or their college or their school or their department. Go find them, or when you get to your new school, talk to your director and the other people in your group and say, hey, what do you help with? Who do you know on campus that does this sort of thing? It's going to save you some time when you start in on your on your new role at your new university or your new role at your old university. If you go out and discover those people that are already doing at least part of the job that you've been hired on to do. So just wanted to give that encouragement, I guess.
And we're running close on time. Jerry, can you give us some insights, some good advice?
Yes, quickly. I want to echo what Jim had said about finding the right people. I went to Taxter last fall. For those of you all who aren't aware of it, it's a really cool research forum at TAC, Texas Advanced Computing Center in Austin. And they offer it once a year. It's free. And I encourage anyone who's never been there to go there, because there are resources, not only just computing, but people who can give you insight into helping your users. In fact, if I didn't go to that Taxter, I would not have known to use the Jetstream cloud service that they have. It's through Exceed. You have to write a grant to get time, but once you do get time, it's a very valuable tool where they have resources available of all types that you can use for prototyping for applications for users. In my case, it was virtual machines for big data. And so it solved a big problem because not all the students had the cyber infrastructure to run the VMs because not everybody has a robust laptop or a robust desktop. So we were able to run the VM on the cloud, and so then nobody had to go out and buy a new laptop just to take my class. And we have users that suffer in the same way. So I encourage you to look into Taxter. There's going to be one this year, everybody. And also, like Jim had said, find the experts on campus who can help make your jobs easier, because chances are the problem has been solved.
In the room, any last questions, comments? You're done, end of day, ready for the wrap up, past time. I hear it, I see it. Any more last comments for the poll? Was the poll good or bad? Raise your hand if it was good. Oh, that's not bad. How was the back row? You guys enjoy the poll? Good, thank you. I'm glad anonymous poll. Yes, question.
Question on Taxter. Is it only for people in Texas, or is it all of them?
Yes, only in Texas, not for you. You can't go. I assume it's spelled Taccster. We lost Jerry.
Yeah. Yeah, Taxter. Taccster.
Yeah.
And I'm not aware of any restrictions. I mean, I've seen folks come from out of state go there, so I would.
That's because on the page it said Tax Symposium for Texas Researchers. So.
Oh, well, I've seen some folks from out of state show up there, but I guess they just showed up. I don't know.
We will find out. Henry has Dan Stanzio's text. You're going to find it. We'll figure it out. Any more questions? Dirk, you're just rubbing your hair. Okay. All right, well, I think I'm going to call it quits. Thank you guys very much. Thank you for your input. Panel, thank the panel. That was a great job remote. Yes.